Imagine a massive wall separating the people who write software from the teams forced to keep it running in a warehouse. Take an e-commerce company trying to build a simple new checkout feature. Under the traditional system, they start with a completely linear process. This image shows the standard software development lifecycle. Notice the top section, a linear sequence from requirements through maintenance. This is the waterfall model. The team plans upfront and moves through distinct phases over months, with no flexibility to go back. After weeks of coding, the developers finally finish the feature. In a traditional setup, they simply throw that completed code over the proverbial wall to the operations team, who manage the servers. At that point, the developers wash their hands of the responsibility and move on to the next project. But when operations deploys that code to live servers, it crashes. The environment is different, dependencies are missing, and users get error messages. Suddenly, the developers insist their code works perfectly on their laptops, while operations blames the code for the failure. A broken, siloed culture makes failure expensive. When these teams work in isolation, discovering a bug takes months, turning feedback into a slow, agonizing ordeal that delays the entire project. DevOps solves this gridlock by merging development and operations into a single unit. Instead of handing off work, these teams build, test, and run the software together from start to finish. To make this work, the team drops the rigid waterfall model and adopts an agile methodology. Rather than building everything at once, they work incrementally, delivering software in small, flexible pieces. This diagram shows Agile and Scrum. Instead of 6-month plans, teams work in sprints, holding daily stand-ups to discuss progress. Looking at the Jira panel, you see how they manage tasks, visually moving bite-sized items from to do, in progress, to done. Breaking massive projects into microtasks and communicating daily dismantles the wall of confusion. By keeping everyone aligned on small, frequent updates, the team minimizes the risk of a catastrophic failure at the end of the line. Cultural alignment is only the first step. To deliver features quickly and reliably, they need raw speed, which requires stripping out as much manual technical work as possible. Examine the green panel detailing continuous integration, or CI. Instead of holding code for weeks, developers push updates daily. The moment code is merged, the CI system automatically compiles it and runs automated tests. Automated tests flag breaking code instantly, letting developers fix errors on the spot. Moving right, continuous delivery preps code for release, awaiting human approval. Alternatively, continuous deployment sends passing code straight into production automatically. These two approaches manage risk differently. A major bank, which needs strict control and regulatory sign-offs, will typically rely on continuous delivery. A software startup optimizing for rapid feature releases will choose continuous deployment to push updates directly to users as fast as they can write them. To support this constant flow of code, the operations team introduces infrastructure as code. Rather than manually clicking through menus to configure a new server, they write configuration scripts. Running these scripts provisions entire server environments in a matter of seconds. By combining automated CI/CD pipelines with scripted infrastructure, the team transforms a fragile, manual release cycle into a highly automated superhighway. A feature that took months to reach the customer can now reach them in hours. Pushing the code to the live servers is only part of the process. The real test begins when the software has to survive unpredictable, real-world customer traffic. To handle this, the team relies on constant, automated monitoring. Tools continuously track vital metrics, like server memory, CPU usage spikes, and error rates, giving the entire team real-time visibility into the health of the application. If a sudden influx of shoppers causes the new checkout feature to glitch, the monitoring system catches the spike immediately. It sends an automated alert straight to the unified dev and ops team, often before a single customer has time to complain. This visualizes the complete DevOps lifecycle. Notice how the monitor phase loops directly back to the plan phase. That alert triggers the process to start over. The team plans a fix, codes it, and runs it through the testing pipeline for deployment. DevOps is the ultimate combination of speed, quality, and rigorous collaboration. It takes software development from a slow, finite event prone to failure and turns it into an infinite loop of continuous improvement.